All right, so lesson 3. So far we reviewed how to use the Pythagorean theorem. We've labeled triangles. We've used that knowledge of labeling to find missing angles in triangles. We also use the angle sum rule. And today we're going to use our trig ratios to find side lengths. Now we already know we can use the Pythagorean theorem to find a missing side length if we know two side lengths. But sometimes we only know one side length and we might know two angles, the 90-degree angle and another angle. So in that case, we can use the trig ratio to find the missing side length. Now to do this, we have to do some setting up the equation. Now, when we're doing this, so we're using trig ratios to find side lengths, we either have to solve for either the numerator or the denominator in a trig ratio to find an unknown side length. Now, this is part of the reason we've done our equations unit, because we're going to use our knowledge of rearranging equations to help us. Now, if the triangle includes a given acute angle, right angle, and one side length, bottom of the ratio, so if the numerator, we have to find the numerator in the ratio, then we're going to, this is our thing, we're going to find the reference angle, label the sides. Remember, your reference angle is not your 90-degree angle. We'll label the sides, we'll choose the ratio we're going to use, and then if the top number is what you're finding, we're going to cross multiply to solve. We'll do some examples. So this is what I say. We circle the reference angle, we label, we choose the ratio using our SOHCAHTOA, and then we solve. Okay, so we're going to do some examples. Okay, find the unknown side in each. So let's look at the first one. So we have a given angle, 39 degrees, which is B. Okay, so we're going to circle our reference angle. Then we're going to label. Well, we know this is our hypotenuse, and we know this, it's right next door to 39, so it's our adjacent. So thinking about SOHCAHTOA, we have hypotenuse and we have adjacent. So we're going to choose to use ka. All right. So that means cos of 39 degrees is equal to our adjacent over our hypotenuse. So actually I should write this as cos of theta just for now. And then in this next one, we'll put in the 39 degrees. Our adjacent is x, that's what we're looking for. And our hypotenuse is 4. Now, then we're going to cross multiply. That's because this is like having a little 1 there, right? So we're going to cross multiply and divide. So what that tells me is x will equal 4 times cos of 39 degrees divided by 1. Cos of 39, we put 39 in and we hit our cos button. This is 0.7771. We don't even have to write the divided by 1 because anything divided by 1 is the same. So we get 87 point, and we'll say 5. And we don't have units. That is not right. Mrs. Finley, what are you doing? 4 times 0.7771. That's 3.1. I don't know what I pushed there to get 87. 3.1 is our answer for x. Okay, so that is our solution, 3.1. Now sometimes we have units, in this case we don't. Okay, now if you'll notice, every time we're cross multiplying in these situations, it's over 1, so it's divided by 1, so we can just eliminate that. We can just multiply the denominator times our trig function. Okay, and if you put in your cos 39 and didn't get 0.7777, then you might be in radians and not degrees on your calculator. Okay, let's do the next one. These ones are delightfully easy. So we find our reference angle. It's the 73 up here, so that's our reference angle. So we circle it, okay? And then this here is our hypotenuse. It's across from the right angle. And this one is our opposite, because it's across the triangle. So thinking about our SOHCAHTOA, if I am going to choose, I've got opposite and hypotenuse, so I'm going to use SO. Okay, so sine of theta is equal to opposite over hypotenuse. We know our theta is 73 degrees. Our opposite is 13. Oh, no, it is not. That's our hypotenuse. Mrs. Finley's making all sorts of mistakes today. Our opposite is x, and our hypotenuse is 13. And then we're going to cross multiply to solve, because this is like it's over a little imaginary 1. So we get x is equal to 13 times sine of 73 degrees. So x is equal to 13 times 73 degrees. Sine of 73 is 0.9563. So times that by 13, and we get 12.4. So this would be our solution. Okay, and that makes sense because it's still smaller than the hypotenuse. Same thing on the other one. 3.1 is smaller than the hypotenuse, so it is a reasonable answer. Okay, let's do the last one here. You'll notice the reference angle can go in any location. Doesn't matter if it's in the top or the bottom. It is still your reference angle. So this is our hypotenuse, and this is our opposite. So looking at that for our SOHCAHTOA, opposite and hypotenuse is going to make me use sine, right? Because I've got opposite and hypotenuse, okay? So from that, we're using sine. Sine of theta equals opposite over hypotenuse. So sine of 53 equals x over 14. We're going to cross multiply. So x will equal 14 times sine of 53 degrees. Now, often I give you this. I'll write it out. 53 sine. You don't have to. You can just multiply. It's true. So we'll get x is equal to 11.2. It's 1/8, but I've rounded up. Okay? So when the one we're looking for is in the numerator, it is actually easier. Okay? Because you can just do that cross multiplying. Sometimes the one we're looking for, the side we're looking for, is going to be in the denominator. And that's what we're going to look at next. Now, you can use your rules for solving equations to solve them either way. So, if the triangle includes an acute angle, right angle, and one side length that is the top of the ratio, so we have x in the numerator, this is the procedure. First, you're going to find a reference angle. As I like to say, that's a circle. Then you are going to label the sides, circle label. Then you're going to choose a ratio, choose, and then we're going to solve. Okay, and if the bottom number is what you're finding, you're going to cross multiply and divide to solve. But now it's going to get a little trickier. So you're still cross multiplying and solving. So let's see what happens. So circle. Oops. Ow. Mrs. Finley just bumped her elbow. Okay, circle. So we circle B. We're going to label. This is our hypotenuse, and this is our adjacent. So thinking about SOHCAHTOA, and you'll notice I'm writing it out to get you guys used to it. Looking at SOHCAHTOA, I've got adjacent and hypotenuse. Well, I've got adjacent. I'm looking for hypotenuse. So let's write that out. So cos of theta equals adjacent over hypotenuse. Now let's fill in what we know. For some reason I wrote an S. Cos of 60 degrees is equal to, our adjacent is 12.9, and our hypotenuse is x. Now, remember, this is like it's over 1. We're going to cross multiply and divide. So when we do that, cross multiply and divide. So how does that work? Well, that means I'm going to have cos of 60 degrees times x is equal to 12.9 times 1, or x is equal to 12. I'm going to divide both sides by cos of 60 and I will get x is equal to 12.9 over cos of 60 degrees. Now, I didn't have to write all that out. I can just know that I'm going to cross multiply this way and then divide by what's left over. Okay, so when I do that, 12.9 divided by, well, what's cos of 60? 60 cos is 0.5. So x is equal to 12.9 divided by 0.5, or 25.8. Okay, so this next one I'll kind of do it in a more shortcutty way. Okay, again, I'm going to write out my SOHCAHTOA because I know I'm going to need it. All right, we're going to circle. We're going to label opposite and adjacent, right? I don't know my hypotenuse. Opposite and adjacent, so I'm using TOA. So let's see what happens. So tan of theta is equal to opposite over adjacent. So tan of 53 degrees is equal to, opposite is 3, adjacent is x. So we remember this is like it's over an imaginary. We're going to cross multiply and divide by the remainder there. So that will be x is equal to 3 divided by tan of 53 degrees. Tan of 53 is 1.327. So x is equal to 3 divided by 1.327 is 2.26. We're going to write that as 2.3. We're just going to do one decimal place. Okay. Alrighty, and once you have that, then you could use those two sides to find your missing side. Okay. Let's do this last one here. So, sorry. So, TOA. So we're going to circle. We're going to label. This is our hypotenuse. This is our opposite. So we have opposite and hypotenuse. So that means we're going to use so, right? So let's do that. So sine theta equals opposite over hypotenuse. So it's sine of 35 degrees equals 9 over x. We're going to cross multiply and divide. This is like it's over 1. So we're going to cross multiply and divide. So we will get x is equal to 9 divided by sine of 35 degrees. So x is equal to 9 divided by 35. Sine is 0.5736. So when I divide, I get 15.69, so I'm going to round that to 7. Okay, so those ones are a little trickier. Basically, you're going to find yourself in the position of taking that numerator and dividing it by the trig function. Okay, so this is now we can find a missing side using trig functions. We have another way of finding missing sides, and that's using Pythagorean theorem. It all depends on the information that you've been given.